Hello everyone, in this presentation, we will focus on microservices and service mesh that have been studied in the frame of the Task 2.2 of the Atlantis project related to resiliency and self-healing by design. Microservices and service mesh with a focus on Linkerd and Istio. Microservices, also known as the microservice architecture, is an architectural style that structures an application as a collection of services. Microservices are independently deployable units, such as JAR, WAR files, OS executables, or Docker images. They have two forms of dependency: runtime, which affects availability, and design time, which impacts development speed. They allow large applications to be broken into smaller, independent parts, each handling a specific responsibility. Their adoption has increased with DevOps and continuous testing, as seen with companies like Amazon, Netflix, and Uber moving away from monolithic architectures. Difference between microservices and monolithic architectures. The monolithic architecture consists of applications built as large, autonomous units. Such applications cannot be changed easily because the entire system is heavily interconnected. Even a tiny modification to the code is likely to require creating and deploying a completely new version of the software. Monolithic applications are also difficult to scale, as scaling a specific function would require scaling the complete application. Microservices address these problems of monolithic architecture by taking a modular approach to software development. In simple terms, microservices reimagine applications as a combination of multiple individual, interconnected services. Each service runs a specialized process and is deployed independently. If needed, the services can store and process data using different techniques and can be written in other programming languages. What is a service mesh? It is a way of managing communication, accessibility, and data sharing between different parts of an application, especially in complex applications made up of many small services, known as microservices. Just as a microservice architecture enables multiple teams to work concurrently on different services and deploy them separately, using a service mesh enables those teams to focus on delivering business logic and not concern themselves with the implementation of networking functionality. In other words, service mesh is a dedicated infrastructure layer for managing communication between services in a microservice-based system. It handles inter-service communication through proxies, implementing features like encryption, load balancing, and observability. How service mesh works. A service mesh improves the manageability, observability, and security of microservices by using proxy-based communication. Proxies act as intermediaries, routing all traffic efficiently. Its architecture includes control plane, manages network policies, traffic routing, security settings, and monitoring. Data plane, handles data flow with sidecar proxies, which manage tasks like security and monitoring independently from the services. A service mesh architecture layer decouples communication from the application logic and uses a proxy or sidecar to manage communications between services and control plane. Web services typically interact through APIs left in the diagram, but a service mesh architecture, right in the diagram, separates those communications from the application logic and manages them through the control plane and a proxy or sidecar. A service mesh framework typically provides many use cases that make containerized and microservices communications more reliable, secure, and observable. Reliability, managing communications through sidecar proxies, and control plane improves efficiency and reliability of service requests, policies, and configurations. Specific capabilities include load balancing and fault injection. Observability, service mesh frameworks can provide insights into the behavior and health of services. The control plane can collect and aggregate telemetry data from component interactions to determine service health, such as traffic and latency, performance metrics, distributed tracing, and access logs. Security, a service mesh can automatically encrypt communications and distribute security policies, including authentication and authorization, from the network to the application and individual microservices. Centrally managing security policies through the control plane and sidecar proxies helps keep up with increasingly complex connections within and between distributed applications. Decoupled communication. A service mesh separates the network logic from the application or business logic of individual microservices, ensuring uniform execution and management throughout the entire system. Microservices and service mesh are important for Atlantis. Why? Because it will add an additional security layer to the Atlantis modules against incidents using redundancy capabilities. Within the context of Atlantis, it is proposed a microservice to be implemented in different containers, where each one possesses a different configurations, OS, architecture, and network topology. Therefore, in case of an attack, the compromised instance should be replaced using another configuration offering the same service with no perceptible changes from the perspective of the critical infrastructure user. This could be implemented and delivered with two different technologies, Linkerd and Istio. Linkerd is an open-source service mesh that integrates with service discovery and control plane tools, ensuring reliable, secure, and manageable microservices. Linkerd's multi-cluster support addresses several challenges. It validates the identity of workloads within and across cluster boundaries, ensuring a unified trust domain. Each cluster acts as a separate failure domain, enhancing reliability. Linkerd functions with both hierarchical and flat networks, providing network topology independence. It extends in-cluster communication features to cross-cluster communication, offering a unified model. Traffic splitting between services on different clusters is possible. In environments with a flat network, Linkerd reduces operational costs by eliminating the need for a gateway intermediary for data plane traffic. Linkerd features are service discovery and load balancing. Simplifies service discovery within a cluster and facilitates load balancing across service instances. Traffic management offers advanced traffic routing capabilities, making it easy to implement canary releases, traffic splitting, and other deployment strategies. Monitoring and tracing provides built-in tools for performance monitoring and request tracing across services, enhancing understanding of application performance and service interactions. Security includes advanced security features such as traffic encryption and service-to-service authentication to ensure secure communication between components. Traffic control allows the application of traffic control policies such as rate limiting, response delays, and retries to enhance application resilience. Horizontal scalability allows to handle large distributed workloads across multiple nodes and clusters. A service mesh is a dedicated infrastructure that manages communication between services within a distributed application. It acts as a network layer dedicated to traffic management, security, monitoring, and operational control between various components of an application. In the context of an orchestrator like Linkerd, which operates as a service mesh, there are several architecture metrics that are crucial for monitoring its performance and health. These metrics help in understanding the behavior of the microservices and the efficiency of the network communication managed by Linkerd. Here are some of the key metrics. Request volume, the number of requests per second passing through the service mesh. It's essential for understanding traffic patterns and identifying spikes or drops in usage. Success rate, the percentage of successful requests compared to the total number of requests. This metric is vital for identifying issues with service availability or functionality. Request latency, the time it takes for a request to be processed and responded to. High latency can indicate network issues, overloaded services, or configuration problems. Resource utilization, metrics such as CPU and memory usage by Linkerd's control plane and data plane components. These are important for capacity planning and scaling decisions. Error rate, the rate at which errors, like 500 server errors, are occurring in the service mesh. It's a critical indicator of the health of your microservices. Traffic splitting, the distribution of traffic between different versions of a service, particularly useful for canary deployments and A/B testing. Service discovery times, how quickly new services or instances are detected and become available for routing in a mesh. TLS encryption metrics, if you're using TLS for secure service-to-service communication, metrics on the number of encrypted versus unencrypted requests are important for security auditing. Pod node-level metrics, in a Kubernetes environment, monitoring the performance of individual pods and nodes where Linkerd is deployed can provide insights into the overall health of the mesh. Network I/O metrics, data transfer rates and errors in the network layer can help identify potential bottlenecks or failing components. Monitoring these metrics provides a comprehensive view of the performance and health of the service mesh, allowing for proactive management and troubleshooting of the microservices architecture. Tools like Prometheus, often used in conjunction with Grafana for visualization, are commonly employed for monitoring these metrics in a Linkerd environment. Istio is an open-source service mesh that provides a way to control how microservices or different parts of an application share data with one another. It is primarily used with Kubernetes, but it can be used with other platforms or standalone in a bare metal infrastructure. Using Istio as service mesh provider reduces the complexity of deployments and takes some of the burden off of your development team. Istio's features let you run a distributed microservice architecture. These features include traffic management, intelligent routing, load balancing, resilience and fault tolerance mitigation, security, automatic TLS encryption, authorization and access control, network policies, observability, monitoring and metrics, tracing and visualization, Prometheus, Grafana integration, service discovery, real-time configuration, policy enforcement, works on multiple environments. Kubernetes installs a kubeproxy component in each node to forward traffic, which has simple load balancing capabilities. Istio acts as the control plane, distributing and controlling the configuration to all sidecar proxies and gateways. Key components of Istio include Envoy, a high-performance proxy developed in C++ to mediate all inbound and outbound traffic for all services in the service mesh. Envoy proxies are the only Istio components that interact with data plane traffic. It handles dynamic service discovery, load balancing, TLS termination, health checks, and rich metrics. Pilot. It provides service discovery for the Envoy sidecars, traffic management capabilities for intelligent routing, and resiliency, timeouts, retries, circuit breakers. Mixer is a component responsible for enforcing access control and usage policies across the service mesh and collecting telemetry data from the Envoy proxy and other services. Citadel. It provides strong service-to-service and end-user authentication with built-in identity and credential management. Kiali is an observability console for Kubernetes and Istio. It provides a deep understanding of how microservices in your Istio service mesh are connected and interact with each other. Integrating Kiali with Istio offers several benefits and functionalities that enhance the observability and manageability of microservices architectures. Kiali offers a set of features that include service mesh topology visualization, real-time traffic flow between services, map of the services, and how they are connected, health monitoring, display error rates, latency, metrics, etc. Configuration validation, analyzes configuration and identifies potential issues. Traffic management, view and edit Istio configuration from the dashboard. Security insights, provides a comprehensive view of security status of the mesh. Tracing, unified view of log and trace information, in this way letting users use logs to identify traces of interest. Istio generates detailed telemetry for all service communications within a mesh. This telemetry provides observability of service behavior, empowering operators to troubleshoot, maintain, and optimize their applications without imposing any additional burdens on service developers. Istio generates the following types of telemetry in order to provide overall service mesh observability. Service metrics, set of service metrics for HTTP, HTTP2, gRPC, and TCP traffic. Labels are supported that provide additional context about the metric being measured. Proxy-level metrics. Istio collects metrics through Envoy sidecar proxies, which generate detailed data on both traffic and proxy functions like configuration and health. These metrics allow monitoring at the level of Envoy resources such as listeners and clusters, requiring an understanding of the service-to-resource relationship. Control plane metrics. The Istio control plane also provides a collection of self-monitoring metrics. These metrics allow monitoring of the behavior of Istio itself, as distinct from that of the services within the mesh. Distributed traces. Distributed tracing in Istio helps monitor and analyze service interactions within a mesh by tracking individual requests across service boundaries. This feature enhances understanding of service dependencies and identifies latency sources. Utilizing Envoy proxies, Istio automatically captures trace spans, requiring minimal configuration from the applications. Access logs. Access logs provide a way to monitor and understand behavior from the perspective of an individual workload instance. Service-level metrics. Istio provides a set of service-oriented metrics for monitoring service communications. These metrics cover the four basic service monitoring needs: latency, traffic, errors, and saturation. Difference between Linkerd and Istio. Architecture. Both products use a similar architecture. The key difference is the proxy used to perform this function. Istio uses the Envoy proxy, de facto industry standard with community, with 300+ companies making contributions. Linkerd 2.0 uses Linkerd 2 as its proxy, which has minimal industry support. Ingress. An ingress manages incoming traffic flowing into a Kubernetes cluster. Istio uses Envoy as the ingress. It provides solid functionality and was specifically designed for cloud-native and internet-scale API environments. Linkerd requires deploying a third-party controller such as Jinx to enable certain features such as rewriting incoming headers. Egress. An egress controls outbound traffic from a cluster. Istio controls outbound traffic using virtual service objects and gateways. Linkerd enables egress management, but it is not straightforward and can only be achieved through DNS and delegation tables, DTAB. Performance and scalability. Istio uses Envoy proxy, which is written in C++ and offers excellent performance. Linkerd uses a Rust-based micro proxy called Linkerd 2 proxy, which drives the entire data plane and offers good performance in smaller environments. Security. Istio provides generally superior security features, including HTTP and TCP support for mutual TLS, MTLS. In terms of policy management, Istio allows various providers to integrate their products into its policy management framework and supports setting rules to limit which applications can communicate with each other. Linkerd supports MTLS by default for all TCP connections. Monitoring. Istio provides monitoring through a tight integration with Kiali. Kiali is an observability tool that can generate metrics, infer network topology, and integrate with Grafana for advanced query capabilities. Linkerd provides out-of-the-box Grafana dashboards that provide insights into service communications. Community support. Istio has a strong community backed by major companies like Google, IBM, and Lyft. Linkerd has limited community support. It was created by Buoyant, which is currently the main corporate sponsor for Linkerd. You can find a more detailed description of these two tools in a dedicated video, also edited in the frame of the task T2.2 of the Atlantis project. That's it for the presentation of the work related to microservices and service mesh. Thank you for your attention. CS Group would like to thank the other partners of the task who contributed to this video: ATC, Siemens, and Vicomtech.